Hello, and welcome to today's lesson. We're going to be going over topics in the Standard 5.1, and we're also going to be looking at topics in the Study Island lesson titled Selecting Graph Types. So if you're working in either of those two places, this is a great place to come to get a lesson and some example problems. As always, remember you should be taking notes because you're going to want to know all of the characteristics of the different types of graphs we're going to talk about today. And once you know those characteristics, it's going to make these problems a little bit easier for you. So make sure you get those copied down in your notes so you have them to refer to and to study. And also remember you can pause at the beginning of a question, work the question out, and then watch the video so that you can check your work to see if you're doing what you're doing right and what you still need some work on. So I'm so glad that you're joining us today, and let's go ahead and take some notes. Here are 4 of the 7 different types of graphs you could see. The first one is a line graph, and that shows change over time. So if we blow up this picture, you can see that it has the different points. So Sunday was 4 push-ups, Monday was 10, Tuesday was 5, and then those points are connected by straight lines. It plays connect the dots. A bar graph compares categorical data. So if we look at this picture, we have a bar graph, and here it's comparing John's scores and Carla's, the different students' scores, without preparation in the orange and with preparation in the green. And it's also comparing between people. So most of them in our lesson today will have the double. It'll be comparing within a category, but it could have single and just be comparing across students or whatever the label is here. A histogram is a special type of bar graph that compares frequencies of numerical data that fall between intervals. So if we look at this example, between 20 and 30, between that interval is 1. Between 30 and 40 is 2. And so you're looking at an interval. That's a histogram. And then a line plot is when you have numerical data that you have a small amount of it, so you want to be able to see every data point when you create it. So, and they often have the X's or some picture above, and it has a key telling you what each picture represents. The next type of graph is a circle graph or pie graph, and it compares categorical data, so not numbers. So here, favorite pizza toppings, pepperoni, cheese, sausage, supreme. This is categorical data as a whole, so it always uses percents. And then you have a stem and leaf plot that it organizes numerical data, so numbers, based on their digits. And it keeps all of the original data, so you have all of the original data points, and it's great for ideal and for range and frequency. So here you have your stem, which is the first place value, and you have your leaf, which is the rest of the place values to the right. And then you always have a key that tells you how to break it down. So here it's telling you the number in the stem is the tens column and the number in the leaf is the ones column. So your stem here would be 0, 1, so that would be 1. And then finally you have a box and whisker plot, and that's used to organize data into 4 equal groups called quartiles. So you see the word quartile there, and it's great for identifying the median. So, and then just some vocabulary words you need to know is this end here is the lower extreme. That's always the smallest data point, and you have your upper extreme, and that's always your highest data point. And then you calculate the middle quartile, which is the median. And then you have the lower quartile, which is the median of the bottom half of the data, and you have the upper quartile, which is the median of the upper half of the data. So here the problem says 300 people were asked to name their favorite ice cream flavor. The results are shown in the graph below, and we have a circle graph or pie graph. How many of the people chose vanilla as their favorite flavor? Well, vanilla is 11%, so we're going to have to figure out how many out of the 300 people is 11%. So we're going to set up a proportion. The 11%, percent's always out of 100. If you get 100% right, you have a whole, you have them all right. So you always put 11 or your percent number over 100. And then you're always going to put your part number over your whole number. Well, our part number is the part of the people that want vanilla. We don't know that, so we're going to put X. And then we know a whole is 300 because that was how many people were polled. So then you just cross multiply and divide. So here I'm going to take 100 times X is 100X. And then 11 times 300 is 3,300. And then I divide both sides by 100. And so X is going to equal 33, and that's going to make my final answer C. This problem says 100 students were asked how many hours of TV they watch per night. The results are shown in the graph below. How many students watched at least 1 hour of television per night? So at least means that you can have 1 hour or more. So I'm going to be looking at these three categories. So 1 hour is 15%. 2 hours is 35%. And then 2 or more hours is 39%. And then I'm going to add those, and I get 89%. And this question is a little bit magical because it's out of 100 students. And percent is also out of 100. So because it's 100 students, no more, no less, it's exactly 100, I can say 89% is the same as 89 students and take a little shortcut. This next problem says there was a survey at Riverside Middle School. 50 students were asked to pick their favorite season of the year. The number of students that voted for each season were recorded in a data table, then a pie graph was made. So here I have to figure out, I have 50 students total. So what part of those is equal to each of these percents that I'm given? If I look at my tables though, I have the column here that has the most difference is fall. So I'm going to start by figuring out my fall. So fall here is 12%. So I'm going to put 12 over 100 equals part is what I'm looking for, and the whole is the 50 total students that were polled. So I'm going to cross multiply. 100 times X is 100X. And then 12 times 50 is 600 equals, I'm going to divide by 100. And then X equals 6. So that means for the fall, I need to have 6. Well, the only answer that has fall at 6 is A. And so I'm pretty confident my number is A, but if I was doing this for a test, I'd want to check out other columns too, following the same procedure. This question here is asking me to match the table with the bar graph above. So if I look, I have every table here is only dealing with Bill 101. So I'm only looking at these three when I go to match. My blue-purple colored column here is at 40%. So that means I need to have a yes at my yes be 40%. Well, that's not A. That's not B. C says that and D says that. So I've got it narrowed down. And then my no is at 39%. And so C doesn't have no, correct, and it also doesn't have undecided, but D has 39%. And if I look at undecided, it's also at 21%, so that also matches. So my final answer is definitely D. Here's a histogram, and it's asking how many students saw between 3 to 6 movies. So if I look, between 3 and 6 is going to be these two columns. This one has 8 for 3 to 4, and 5 to 6 has 10, so I add those together, and that gets me 18, which is my choice A. This problem here gives us a line graph, and it wants to know which of these tables match it. So I'm going to look at 6 years, he weighed 51 pounds. So those are all the same. So that doesn't narrow any out. My next one is at 7 years. So I'm going to go to 7, not 6.5, 7. Don't let it trick you. And he weighed 56 pounds. Well, that's going to narrow out choice A. And then I go to 8. And at 8, he weighed 62 pounds. So I'm just reading the graph. And so that's going to narrow out C. And then at 9, he weighed 70 pounds. And the only one that has all 4 of those is choice B. So that's going to be my answer. Here's a stem and leaf plot, and they want to know what are the original values. So if I don't have a key on my stem and leaf plot, I assume that my stem is the tens column and my leaves are the ones column. So this line here would be 40, 40, and 46 when I put those back together. So this is basically saying I'm going to put a 4 in front of each of these digits. I'm going to put a 5 in front of each of these digits to get 52 and 55. I'm going to put a 6 in front of the 3 and the 5 and get 63 and 65. Then I'm going to put a 7 in front of the 6 and get 76. And then the only choice that has all 8 of those numbers is going to be choice B. The following is a stem and leaf plot that shows the average temperature over the last 10 months. So now, what is the highest average temperature over the last 10 months? Well, that's pretty handy because stem and leaf always starts with the smallest and goes to the biggest. So if I take my last number in my leaf and add the number in my stem back on it, that's going to be 87, my highest number, which is A. Here's a line plot that shows the times Mrs. Andrews' students visited the amusement park during the summer. Each X represents one student. How many students have visited the amusement park 2 or 3 times? So that means I'm going to be looking at these 2 columns for 2 or 3 times, and then I just count the X's. This one's 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11. So that means 11 students went 2 or 3 times during the summer. Here's a box and whisker plot that shows the ages of people attending the 2 Sunday afternoon movies. So what is the difference between the median ages of the people that attend the 2 movies? Remember, the median for my notes always comes from this line in the middle of the box. That's our median number. So this line here is above 30. So movie 1, the median is 30. And then the second movie, the line is above 45. So that means our median for the second movie is 45. And when you take 45 minus 30 to get the difference, that's going to be 15, which is choice C. Here's another box and whisker plot, and it indicates the average rainfall per month in inches for the whole last year. What can be interpreted from this box plot? Well, from our notes, remember each of these is called a quartile. That means each one has a quarter of the data. So a quarter of a year, if you have 12 months, you can break that down into 3, 3, and 3. So each of these represents 3 months of rain. So the first 3 months, they got 2 inches. So that's going to make A my answer. Let's go ahead and look at B, C, and D, though, to make sure we're right. 6 months, they had, 3, 6, they had 3 inches of rain, so it wasn't B. And C is saying that for the first 3 months, they had 2 inches of rainfall or more. No, they had 2 inches or less. And then for the first 9 months, so that would have been the first 3 blocks, looks about 4.5, but it says 1 inch, so it wasn't D either. So my final answer is definitely A. So here is Brock is trying out for his school's track team. Here are the most recent times on the 400-meter sprint, and there's 6 numbers. What is the correct classification of his times? So if I look at this part of the chart, everything's the same for all my answers. So how many numbers are between 61 and 65.9? So here's 1, and here's 1. So there's 2 in that first range. And then my second range is 66 to 70.9. There's 1, so there's just 1. So there's going to be 1 in that second range. And then my last range is 71 to 75.9. And if I look at that, there's 1, 2, 3 of those. And so the one that says number of times 213 is choice A. This question says, which of the following is not a question to ask when selecting a graph type? So which one of these doesn't matter when you are picking a graph? Is the data made up of percentages or parts or wholes? Well, that one matters. Is the data old? No, it doesn't matter how old the data is when you're picking a graph. You don't pick you don't pick a histogram over a line graph because it was 1950 versus 2005. So it's choice B. The following questions you have to pick the best graph. So this one says, which graph type would best be suited for showing the lower quartile of the high temperatures last night in Philadelphia? The key word here is quartile. Anytime you see quartile, it's always going to be B, box and whisker. Number 15. Which type of graph is best suited for displaying the population over a certain city over consecutive 10-year periods of time? So anytime you're talking about for a length of time, that's either going to be a line graph or a histogram. And because histogram is the one that's there, line graph isn't, B, histogram with the intervals is going to be your best choice. Which type of graph would best represent the grades of 30 students on a mapped test so that each individual grade can be seen? Well, I'm looking at it in the circle graph and box and whisker graph. You're going to lose your original data because it's going to go to percents or quartiles. In a line graph, you typically only like to have 1 point for each number, whereas when you have scores, you could have multiple people score 100 or multiple people score 85. So that's what a line plot would show you, how many people get each of those scores, and it's a much better representation. 17 says, a construction company manager wanted to know who his most efficient dump truck driver was. He recorded the number of dump truck loads that each of his 3 drivers completed from June to September. What type of graph best compares how many loads each driver completed per month? So if you look, a scatter plot, that's not one that we've talked about. A pie graph always uses percentages. We don't have percentages. A line graph doesn't really compare across categories, but a bar graph does compare across categories, so it's going to be D. Which type of graph is best suited for graphing the weight of a child as he or she ages? So over a length of time. Remember, over a length of time is either going to be a histogram or a line graph. So then you have to think about, is it going to be a specific time or over an interval of time? And since you would do it at, 1 year, 2 years, 3 years, not, what did he weigh between 1 year and 2 years, that's going to change. It's going to be a range also. You can't plot that. So it's going to be line graph A. This last question says, what type of graph is best suited for displaying the percentages of students in each level at school? The key word here is percentages. The only graph we've talked about that uses percentages is a pie chart. So it's going to be my final answer, A. Thank you for joining us today, and I hope you learned something new.